My name is Aline Dantas from the Federal University of Pernambuco in Brazil. My research is about analysis of physical-chemical alterations resulting from dissolution tests in synthetic carbonatic rocks, and my secondment duration was between April 13 and May 13. A brief contextualization. The global oil industry moves a huge part of its economic resource to support exploration and production of oil and natural gas. In order to maximize production, there are well stimulation techniques. Matrix acidification is one of these techniques and is defined as any intervention performed in a field in order to obtain an increase in the petrophysical characteristics of the porous medium, facilitating the flow of the fluid in the medium. This technique was being used in pre-salt reservoirs, which are predominantly carbonatic, but with a complex porous system. So, a wider understanding of this type of reservoir is important. Parallel to this understanding, there is the CO2 injection technique, which besides helping to increase production, can be used as a form of storage of this greenhouse gas in geological formations. My work consisted in studying the physical-chemical change caused by the injection of reactive fluid in samples of synthetic carbonatic rocks through dissolution tests using a cell constructed at the Federal University of Pernambuco. For this, two cells were constructed. The compaction cell was designed to obtain a sample with stable mechanical properties and help to increase the material compactness for the production of a carbonate rock. The dissolution cell was based on the research developed by Melo, also from Federal University of Pernambuco. A new cell was built for the purpose of this research, and a synthetic carbonate rock with smaller volume were made than the one seen in research by Melo. Here it's possible to observe the compaction and the dissolution cells used in my research. For procedure for preparation of synthetic carbonate rock, we had the rock composition of 50% quartz sand, 25% calcium hydroxide, and 25% alimida, which are carbonate fragments. The dry material were weighed in a same analytical balance, mixed and homogenized by hand with distilled water for about 5 minutes until a homogeneous mass was formed. Subsequently, the material was deposited in a compaction cell where static compaction was performed. The target value for height of the compacted sample was 8 cm. After the static compaction step, to maximize the cementation of the carbonate rock, the sample was submitted to a direction carbonatation, where a pressure of 100 kPa of carbon dioxide was applied in the upper open of the compaction cell for 4 minutes. After 24 hours, the synthetic carbonatic rock was extracted from the compaction cell with the aid of mechanical extractor. Some analyses were performed for petrographic and mechanical characterization of synthetic carbonate rocks. A structural analysis of the rock with digital microscopy, analysis of rock resistance with tests of uniaxial compaction strain of the rock samples before the injection of the reactive fluid, and a qualitative analysis of porosity with a qualitative study of physical-chemical change occurring internally in a rock. For dissolution tests, we have a study of a permeability variation with continuous measures in 3 similar synthetic carbonate rocks. The rocks are submitted to different pHs and the permeability was measured from the Darcy law with percolated volume and percolation time. Here we have the dissolution cell ready for the start of the test. The result of a structural analysis of the rock before the dissolution test showed the compaction followed by CO2 passage through the sample and the main component of the rock and its heterogeneity. The value of the estimated uniaxial compressive strength was 2 MPa, a low value when compared to the resistance found in natural rocks, but with this value the rock was still considered as a soft carbonate. Limitation of the compaction equipment may have prevented the rock from reaching a higher density. Tomography were performed before and after the passage of the reactive fluid. It was possible to observe, in all cases, an increase of the porous volume. However, this analysis was only used as an observation and comparison tool, attributing a knowledge to the events arising from the dissolution process. In AM1 sample, an abrupt increase in permeability was observed, ranging from 0.07 to 3.53 Darcy. This occurred due to the formation of a dominant preferential channel, a wormhole, that started to conduct the entire solution flow as shown in the figure. Analyzing the graphs, it is noticed that the pH of the percolated solution is reduced exactly at the point where there is a greater increase of permeability, leaving at the moment a pH value of 11.5 to 2.2. In this case, possibly the system has been found to be in equilibrium, and the flow passage of the acid solution is being performed only through the formed wormhole. In the next sample, more uniformity is observed in the dissolution. However, the formation of preferential paths of different size is still well visible, resulting from the rapid dissolution of areas with higher concentration of calcite. The initial permeability of the rock was 0.06 Darcy, very similar to the AM1 sample, and presented a final value of 1.66 Darcy, with a final percolated fluid pH of 6.24. In a study by Alcatan, it is possible to observe the relation of the rate of dissolution of the carbonates with a pH. In Alcatan, tests were performed varying the pH from 1 to 3, and it was observed that the reaction rate for rocks subjected to the fluid in this pH range was higher than the speed found in the test with the other pH values. From this and the results obtained with the test of the rock submitted to the fluids of pH 2 and 3, it was decided to reduce the acidity of the reactive solution in the test with the carbonatic rock AM3, and therefore they observed the influence due to a speed of reaction of the carbonate. For the rocks subjected to pH 4 fluid, since the reaction occurred more slowly in relation to the other rocks, it was possible to observe more uniformity in the chemical solution than in the previous tests, reaching the same permeability behavior followed by the greater uniformity. The initial permeability of the rock was 0.03 Darcy, and the final permeability was 0.3 Darcy, a 10-fold increase in the initial permeability value. The main conclusions shows that there were significant modifications in the petrophysical properties of the medium, as change in rock resistance, dissolutions of the mineral present in the porous medium, and change in permeability and porosity samples. Thank you very much.